Okay, folks, and the last part is the simple trinomial factoring. If you came either from grade 10 applied or academic math, you certainly would have factored. And same thing, it would have been the simple trinomials realm. We are only going to be dealing with when the a value on the x squared is equal to 1. Very similar to what you did last year, just the basics of factoring. You'll also be happy to know that because of the speed of the class, we're only going to focus on the positive case. If we run into negative factors, we'll have other methods to assist you like Desmos. So this probably will mostly be a review because I think a lot of you would have worked with product sum last year, but we're just going to rock through some examples, and if there's any questions, of course, you just let me know. So the first equation that we are going to work with is x squared plus 3x plus 2. Notice one thing. So the x squared does not have a number attached to it, and this is called standard form. Standard form, ax squared plus bx plus c. That's what we're looking at. So standard form, otherwise known as the form with no brackets. When you are factoring, there are reasons why you would factor, and the number one reason is to find your x-intercepts or find a vertex from your x-intercepts. We're going to try to break this down as simple as possible. So, the moral of the story, we're going to ignore all the fancy terminology and all the very wild ways that you can figure it out. You want to multiply to the last number and add to the middle number. Okay? So, just to repeat myself so that we just keep things very simple, you want to multiply to your c value, which is the last number, and you want to add to the middle number. When you're doing this, it's going to be 2 factors. Okay? If I'm even describing it hard, I'm just going to show you because I think it'll be a lot easier. So, how we approach factoring typically with simple trinomials is product sum tables. So your product, I'm just going to keep as the blue. Your sum is going to be the purple, and hopefully you can see these colors here. So again, this is called a C value, and this is called a B value. How I usually approach factoring in classes is the first part is getting your product sum table set up. Much easier to go through actual numbers rather than describe it abstractly. So I know that my product is going to be 2. I always want to make sure I'm multiplying to the last number. My sum is the purple highlighted middle number, which is 3. So once I get my setup, once I have some stuff highlighted and indicated, then I am pretty good to move forward in a sense and start solving. You're always going to be finding product or sums based on a factor of 2 numbers. So here's how I'm going to do it. I'm going to go through all the numerical pairs that multiply to 2. Only 2 numbers, please, not 3 or 4. Now, 2 is an interesting number. It's prime. So the only 2 numbers that multiply to 2 are 1 times 2. Okay? So our first step, we're going to list out all the pairs that multiply to our number labeled product. Okay, or the last number in our string. We then move to the right-hand side to our sum, and typically we will check all of our answers, but because we only have one option, we know it's got to be 1 plus 2 is equal to 3. Okay, we got lucky because our numbers, there's only one option. So, our factors itself are 1 and 2. Okay, sometimes I tend to box them just to indicate that it worked for both the product and the sum. How you rewrite this is you're going into factored form. Again, we're only dealing with positives, so it will always open up as the following form. So x plus factor 1, x plus factor 2. Okay, you're going to take those 2 numbers and you're going to apply them. So we have plus 1 and plus 2. Boom, you just factored. If you went ahead and FOILed this out, which you can try on your own, you would get x squared plus 2x plus 1x plus 2. 2 plus 1 is 3 on the x's. So you could always double check your work by going ahead and multiplying out. Okay, this example is a little bit more straightforward because there's really only one option. Let's try one with more options. So another example is x squared plus 9x plus 20. Okay, I'm going to follow a very similar procedure here. So I am going to get two numbers that add to 9 and that multiply to 20. I'm personally going to stick to the same method. I find the same method is usually easier, especially in a fast-paced learning environment. So I'm going to start building a product and sum table. Okay, some people just write P and S, just standing for product and sum. You can set this up however you like. I just writing the full words in case you're not too familiar with it. So our sum is 9. Our product is 20. I always start on the product side because if things don't multiply anyways, you obviously don't want to use it, right? There's usually more ways to add to a number than to multiply. So that's the reason why typically we start on the product side. I am going to go through and I'm going to list all of my pairs that multiply to 20. So the bigger the number, the likelihood the more pairs, unless of course it's prime. So I have 1 times 20. I also know 2 times 10 equals 20. I don't think 3 works. I can do 4 times 5. 6 doesn't work. 7 doesn't work. 8 doesn't work. And 9 doesn't work. And now I'm back to 10. So notice how we basically went from 1 to 2 to 4 to 5. And then once we got back to 10, we realized there's probably nothing else, right? So we have 3 pairs this time instead of just 1. Step 1 is complete. If we put in any of these factors, it would multiply to positive 20. The next part, you are going to check your sums. So you can do this by inspection. Some of you might look at this right away and see what 2 numbers add to 9. Or you can double check by going through all of your pairs and trying to add them up. Okay, to start, 1 plus 20 equals 21. It does not work. 2 plus 10 equals 12. We're getting warmer, but it did not work. 4 plus 5. Oh, that works. It equals 9. Therefore, our 2 factors we want to put into factored form with the understanding of the product is 20, the sum is 9, is 4 and 5. Keep in mind, everything's going to always be positive. So you don't need to worry about signs or anything like that. Just please focus on the numbers. Some of you might have looked at those numbers on the side and right away said, I know it's 4 and 5. Okay, so if you know it, feel free to hop right into your factored form. Same thing as before, we're going from standard to factored. So we are going to open up our brackets and just write it as x plus 4 and x plus 5. That is our final factored form. We're going to leave it just like that. Okay. Question that might come up is, what if you start going through your products, you try all of your sums and none of them work? Okay, so this can happen. A, go back in your pairs. Did you miss a pair? It's very possible, especially if the number was larger, that you missed a multiplicative pair of your products. Number 2 is some things are just not factorable. Any quiz or assessment, the numbers will be factorable, I promise. So, to be honest with you, just go back to step 1. Double check your factors. If there's anything missing, just try to see if you can catch it. Okay. And the last one is, we will try something else, is x squared plus 6x plus 9. Okay. This is going to be a bit of a special case, so just really try to pay attention as we're going through this one. So, same thing, I know I'm going to need a product sum table. I'm just going to start setting it up. your product is going to be your last number. So you're going to want to multiply to 9. And you're going to want to add to positive 6. My setup is all the exact same, so maybe take a second, get yourself set up. If you're like me, like colors and visual cues just to get yourself sorted, feel free to do that. Okay, so again, without going into too much detail where I confuse you, we're going to stick to the exact same process as the other two. We want to multiply to the last number, we want to add to the middle number. So for our product, I'm going to go through and see what pairs of numbers multiply to 9. I know 1 in itself will always multiply. I also know 3 times 3. I can't think of anything else, right? I really just, like 4 doesn't work, 5 doesn't work, 6 doesn't work. If you are not sure, you can try dividing 9 by these numbers in your calculator and see if you get a whole number result, okay? I'm also going to throw up a little chart just with some multiplication tables in case anyone forgets. Anyways, I can't think of anything else than these two, so I'm going to move over to the side here. 1 plus 9 equals 10. Okay, it doesn't work. And some of you probably saw it right away. 3 plus 3 equals 6. That works. So these are my numbers. Notice that they're the exact same number. So one of your quiz questions asks, can you just have one factor? The answer is yes. You can have the same factor twice. Okay? So when we're popping it into our factored form, it's basically a repeated bracket. So it's going to be 3 plus 3, x plus 3 and x plus 3. In our course, feel free to leave it like that. Okay, we have the same factor twice, so that's a quiz question again. So hopefully you've made it to the end of this video. When you have the same thing twice, so like x times x, what do? Well, you usually throw it to the exponent of 2. Another way that you could write this is x plus 3 squared. If that doesn't make sense, disregard. Focus on your final answer being x plus 3 and x plus 3. Okay. So again, just to recap, all of our cases are positive. We are only looking at simple trinomial a equals 1. And we are basically just trying to find two numbers that multiply to the last term and add to the middle. Okay, so hopefully this helps. Factoring is one of the trickiest concepts. The first week I ever factored, I was super frustrated, angry. Okay, factoring is not easy. So just make sure that you're taking your time and you're going through all the examples.